Hello and welcome to Fun with Physics. I'm Mr. Spenceri, and this is the third lecture in a series of lectures on electricity and magnetism. Today we discuss the measurement of charge. Electrostatic charge is symbolized by the letter Q and is in the metric system is measured in a unit known as the coulomb, given a capital C symbol. It is named after a French scientist named Charles de Coulomb. In 1911, an American scientist by the name of Robert Millikan performed an experiment to determine the charge on an electron. The experiment is explained as follows. He took a bottle of oil and sprayed the oil droplets finely onto a parallel plate capacitor with a hole on top. The oil droplets varied in mass and also varied in electric charge due to the frictional motion of the atomizer. As they passed through the electric field between the two parallel plates, some droplets accelerated downwards, some accelerated upwards, and some stayed motionless. By varying the electric potential across these two plates, Millikan was able to balance off the force of gravity acting on some of these droplets with the electric force, and from that getting a mathematical equation relating the two. After doing this experiment a numerous amount of times, he realized that the charge on these oil droplets changed by a multiple, and the lowest common multiple was 1.602 times 10 to the negative 19 coulombs. He concluded that this must be the lowest possible charge transferred from one object to another, and therefore must be the charge on an electron, and therefore also the charge on a proton, but positively charged. So the equation in the box in the middle of the screen shows how we can determine the overall charge on an object if we know the number of electrons in excess or in deficit, or the number of protons in excess or in deficit that an object has, and multiply it by the magnitude of charge on one electron, which is a constant, once again shown at the top of the screen, 1.602 times 10 to the negative 19 coulombs. Let's use an example to further clarify how this equation can help us. Jordan put his wool socks and a silk shirt together in a dryer after washing them. When he took them out, he noticed that the wool sock and the silk shirt were stuck together because of an electrostatic force of attraction. If 3.7 times 10 to the 4 electrons were transferred between the wool and the silk, what is the amount of charge on the silk shirt? So, looking at this problem, we notice that we are given the value of how many electrons were transferred between the wool and the silk clothing. Under our givens and unknowns, we can write down that we do know the charge on an electron, and we know the number of electrons, and we are solving for the total charge that was transferred between the two pieces of clothing. So the equation that we're going to use is that we had on the latter page, and the solution is done by plugging in our values. And we come out with a value that should be negative because it's the amount of electrons that are transferred, and it comes out to about 6.0 times 10 to the 5 coulombs of magnitude. So this is how we can use the equation to determine the overall charge on objects after electrons are transferred to or from.